Welcome to another fun-filled day of chemistry. Please do the 2 warm-up questions to the best of your ability, and I'll be right back. Question number 1 asks for us to determine if a mixture is homogeneous or heterogeneous. Homogeneous is when it is uniform throughout and all parts of it are all the same and you can't tell any difference between one area and another. Heterogeneous is when you have distinct areas that are separate from the rest, and so that would be heterogeneous. Now when we look at granite, here is a piece of granite. Notice that in the granite there are little speckles and spots. They're separate from the whole. It is not uniform throughout. So granite would be heterogeneous. Air, the air is all the same. If I go to another part of the room, the air is pretty much the same. And if I go to a higher altitude up in the mountains, there's less oxygen, but it's still uniformly distributed. So air would be a solution of gases. It is homogeneous. Gasoline is also a homogeneous mixture. Now you may have a higher octane in the tank, but it's all distributed pretty evenly or very evenly. It's a solution and therefore it is a homogeneous mixture. Wood is a heterogeneous mixture. It has grains in it. So there are rings and there's the bark and there are distinct areas. So that would be a heterogeneous mixture. Blood is also a heterogeneous mixture because blood has red blood cells and white blood cells. And if you're really tired, you might have fewer red blood cells. Or if you're sick, you have more white blood cells fighting off that infection. So it does change. However, they are distinct parts in the blood. So blood is a heterogeneous mixture. Black coffee is a homogeneous mixture. If you take the coffee from the pot and you pour it in a cup, what's in the cup looks identical to what's in the pot. There's no difference, so it's homogeneous throughout. Now in number 2, we're asked to determine if it's a compound, an element, a solution, or heterogeneous mixture. Air, as we said, is all blended. It's all the same all over the place, so it's a solution. Sugar has a chemical formula. Whether it's C6H12O6 or our table sugar is C12H22O11, it has elements combined together chemically. So that makes it a compound. Sulfur is on the periodic chart, so that's an element. Nicotine is in cigarettes, and that is a compound. Those elements are combined together chemically. Concrete is rocks that are ground up, and so the rocks are all different sizes all through the mixture, so it's a heterogeneous mixture. Kool-Aid is uniform throughout. The thing that changes it is that I could put 1 bag of Kool-Aid in a gallon of water or 5 packages of Kool-Aid in a gallon of water. One's concentrated and one's dilute, but they're all still evenly distributed throughout, so that makes it a solution. Insulin is a hormone released by your pancreas. That's a compound. Sodium is an element on the periodic chart. So those are the answers to number 2. Now there's just 2 quick things I need to mention to you, and they're means of separating mixtures using physical properties. Now the first method that we can use to separate mixtures would be using boiling points as the physical property. In distillation, what we do is we take something that has a lower boiling point and drive it off and condense it back and get that substance separated from the original mixture. Now that's what we do with crude oil. We take a barrel of crude oil and you see those refineries, they have the big tall stacks, and the lightest ones with the lowest boiling points come off first. So they come off at the top. That would be like your jet fuels and your kerosene and your turpentines. And then as you go lower and lower, I should say higher boiling points that take longer to get out, then they are heavier. So asphalt and those tars are left behind for the lower boiling points. or the higher boiling point. So the lower the boiling point, it comes off first. Another example would be when we have salt water. Salt has a very high boiling point. So when the water comes off at 100 degrees Celsius and the salt is left behind. So that's one way that we separate salt and water. Crystallization uses differences in solubilities. Which some things will dissolve in water and some things won't. So we can use differences in solubilities to separate these mixtures, and we call that crystallization because they may crystallize in different solvents. Another way is magnetism. Sometimes we separate iron filings out of sand using a magnet. So there's a variety of different methods that we can use to separate mixtures using their physical properties. Now tonight you have Worksheet D, and it's very important that you pay attention to this one. It looks just like one of your assessments. There's a description of an element, and you have to pick out intensive physical properties, extensive physical properties, and chemical properties. So please be careful and pay attention when you're doing that because it looks just like the assessment. So there you go, another day of chemistry. Bye! See you tomorrow.